Hi, everyone. Today we are talking about another type of factoring. We're in this section here called factoring difference of two squares. This is really pretty closely related to the factoring that you were doing yesterday, but if you can recognize these problems for what they are, it should actually provide you with a shortcut. Okay, these problems should be the easiest ones that you do, um, but sometimes I find that students don't always recognize them when they see them. That's really the difficulty here. So I want you to take a look at this first problem, x squared minus 25. And it looks a little different than what we were doing yesterday because yesterday we had trinomials. We had things with three terms, and this one only has two. Um, but realize that what this is missing is that middle term, right? It doesn't have like an x in there. And so I'm going to rewrite this thing as x squared plus 0x minus 25. Okay, now it looks like what we did yesterday. So now, if I approach it like we did yesterday, I'll have x and x, because the x and x give me my x squared. I have a negative sign here, which means I'm going to need one positive number and one negative number. And then I want to think about, how do I multiply to make 25 and add to make 0? Well, the adding to make 0 is possible because I have one positive and one negative. As long as these two are the same number, I should be able to make 0 in the middle. And I can use the exact same number because 25 is a perfect square. Okay, so I should point that out here because that's where this thing gets its name. 25 is a perfect square, meaning it's equal to something that's been squared, like 5 squared. And so if I use 5 and negative 5, I get my 0 in the middle. Okay. Also, and this we kind of take for granted, but x squared is also a perfect square, and that's what allowed me to write it as x times x. Okay, so to get to the shortcut piece, anytime you have a perfect square and a perfect square, all right, and really we should be looking back here, perfect square, with subtraction in the middle, and it has to be subtraction because you have to be able to do one plus and one minus to get your 0. Okay, if it were a plus, I wouldn't be able to do that. So 1 plus 1 minus, so we have a negative sign here, and these two are perfect squares. You can always just factor it into the square root of this and the square root of this. Okay, that's really what I did there, is I took the square root of x squared, square root of 25. That showed up here and here. And then one's a positive, one's a negative. Okay, so let's take a look at this next one. This is getting to be a little bit different because it's got a y squared in it too, and we didn't do anything with other letters yesterday. But once again, this is a perfect square because it's something that's been squared. This is also a perfect square. If I take the square root of x squared, I get x. And if I take the square root of 9y squared, I get 3y. Okay, so my two factors are going to be x plus 3y, and then the exact same thing but with a minus sign, x minus 3y. And if I multiplied those back together, x times x gives me x squared. Technically here I would get a negative 3xy, but then here I would get a positive 3xy, so those would cancel and I'd get my 0 in the middle. And then 3y times negative 3y would give me negative 9y squared. Okay. All right, so that next one looks kind of crazy, but once again I want to point out 25 is a perfect square. X to the fourth is a perfect square. Y squared is a perfect square. So this whole thing is a perfect square. You might not know this one off the top of your head, 289, but if you check it in your calculator, if you try taking a square root of 289, you're going to find that this is also a perfect square. Okay, and z to the 6 is a perfect square. With your exponents, as long as they're even exponents, they're going to be perfect squares. So if I'm going to break this up into pieces, this would be 5 x squared y. And this one here, square root of 289, is 17 z to the third. Okay? So I'm going to have 5x squared y plus 17z to the third. And then the exact same thing with a minus sign. 5x squared y minus 17z to the third. Okay, so that's what you want to be on the lookout for. Anytime I'm trying to factor and I see that it's just two pieces, I see that it's a binomial with a subtraction sign in the middle, this difference of two squares is what jumps out in my head right away. Okay, so you want to get to the point where you're recognizing that when you see it. All right, so let's try that last one. 81 minus 256m to the fourth. So once again, 81 can be square rooted. That becomes a 9. 256, square root of that is 16. And then m to the fourth, when you take a square root, is m squared. Okay. So here I'm going to end up with 9 plus 16m squared. And then 9 minus 16m squared. Now, there's something very unique about this problem, and I don't do this to you very often, but it does happen. Okay. If you look at your results here, 9 and 16 and m squared are all perfect squares again. Now, that doesn't actually matter here because there's a plus sign. And if you look at all of these, we can't do anything with a plus sign. But this guy, 9 minus 16m squared, that's another one of these. Okay, that's another one of these difference of two squares because 9 and 16m squared are both perfect squares. There's a minus sign in between. So this thing here can break up into 3 plus 4m and 3 minus 4m. This one here I can't do anything with because of that plus sign. So this is just going to stay 9 plus 16m squared. And so then I would have 3 parentheses in a row for my final answer. That's really it for today. Difference of two squares. You're about to do an entire page of difference of two squares. I hope that you can get to the point where you could do these things in your sleep. Okay? These ones should be the easiest ones that you do as long as you remember what to do when you first look at them. So that's why I'm making you do it over and over and over again. Okay? All right, that's it for today. Have a good one.